Hello. So let us continue our discussion for chapter 15. So last class, we discussed about the implementation and the concept about a singly linked list uh, using nodes. What we will add for this class is the last class, the single linked list, doesn't support for each loop, so it doesn't implement the iterable interface. And this class, we are going to discuss the singly linked list that's also support for each loop, so it's going to implement the iterable interface also, okay? So the linked list going to support for each loop. And if you recall in the previous discussion, we discussed for each loop, if a collection wants to support for each loop, then it needs to implement the iterable interface. Interface. Okay, and in iterable interface, is one of the abstract method is going to return iterator. So we will also see how we do that in our implementation. Okay, so once the singly linked list implement iterable interface, then it will support the for each loop. And later on, we will see the implementation. So in our implementation, you will also see we define a class we call linked list iterator class. And this iterator class implements iterator. Okay. And if you recall previous, we also learned iterator is also an interface. Okay, so this linked list class is going to implement its interface, the iterator interface. And within the iterator interface, it has a couple of major methods that abstract method that our class needed to implement. It's a has next, next, and remove. So in our implementation, we implement has next method. We also implement the next method, but we leave the remove method there, and you can try it. Okay. And for this class, we also define the constructor. Okay. And for this class, um, it has the data member, so it's the next node, and the type is the node type. Okay, so what has next method, what it does, it returns true or false. Okay, based on the current position of the node. And next, it returns the value from the current node. But be careful, it also advances the current position node to the next node. So that's what this class is going to do. So here is some basic concept, and then let's go to take a look at the coding part. And in our implementation later on, when we test our linked list which supports the iterable interface support for each loop. Okay, and we are going to use the objects of car. So that's why um, in this example, we also define the car class, okay, and in order to support the deep copy, the clone method, so we also define our clone interface and and then let's take a quick look of the car class. Okay, so the car class, it will implement the T-clonable interface that we just defined. The car class is pretty simple, just as name and color. Okay, we are going because we are trying to going to show some features, okay, regarding our linked list using class instead of just a string and integer as our first example shows. So we have the car constructor and we have the mutator, and this is a clone method. Okay, so for the clone method, we are going to make a deep copy of the object itself. Okay. So using the specified name and color, okay, then we return this copy. So that's what this method does. So it's a deep copy. So keep this in mind. It's a clone method. And the toString as usual and the equal as usual. So this equals it will check if the contents are the same, okay, not a reference. So it is not, this is for reference. Or we call it referential equality check, okay, and this is over here we are doing structure equality check. And structure is to check the contents, okay. Okay, and then next let's take a look our linked list. And it's still a linear singly linked list. Okay, so for this linked list, it's singly linked. Okay, but it supports for each loop. Because its goal is to support it for each loop. So that's why over here we needed to implement the iterable interface. Okay. And this link is also generic, but it supports the copy for the generic T type. Okay, supports the deep copy. So that's the major feature that this linked list is going to have. And because of the iterable interface, so let's take a look. For iterable interface, and if you recall in previous chapter, we learned iterable interface has a abstract method called iterator, and it returns a generic iterator. And we also say iterator itself, basically, it's also an interface. interface, is it? Yeah, so what here we need to do is we need to return some instance of an object which implements the iterator interface. Okay, so because we don't have this kind of concrete class, okay? So, and also for the purpose of our own singly linked list. So that's why over here we define uh, our own linked list iterator, okay? This linked list iterator, and we define it as a private inner class. So this is an inner class, regular, okay, inner class, not a static. So it's different from the node, okay. And it will implement the iterator interface. Okay, then let's go back to take a look our linked list. So the new thing that we added based on the first example linked list, the example that we discussed in our previous section, the new is it implement iterable interface and also the type, generic type also supports deep copying. Okay. Other than that, like a node class, there is nothing changed. And the constructor, if you take a look at the code, constructor not change is empty, not change. And for the insert function, we does change a little bit. This time, the linked list is not going to be in ascending order. Okay, so it's any order. It's based on how you insert. So here we insert the new item after the specified item. So that's the change, okay? So similar, when we do insert, we have a couple of scenarios we needed to consider. Is it empty? So this is empty case, empty list case. And over here, we do the loop. And if you recall, and here, because we define cursor, we also define precursor, etc. So over here, we do pair advance. Because here it involves, we are going to insert the item after the specified item, etc. And we want to take care of the case of insert in the middle, in middle, and last. We kind of combine both cases together, okay? So that's why we do this pair advance, and you will see that why we do it. Okay, you see, if it's not the last node, if it's so you're traversing the previous loop does traversing, if that doesn't go beyond the end of the list, it's in the middle. Okay, when it's in the middle, it's the same as what we discussed last class. You just have cursors next as it point to the new node. Okay, the new node next point to cursors next. Okay, but if it is the last node, Yeah, then cursor going to be no. Then how do we know? How can we insert? Is it? So that's how you are going to just have that precursor. Remember the last node's position, and you just add the new node the to its next, is it? And the new node's next is going to be null. Okay, so that's the minor difference here between this implementation and the implementation from last class. And here we have the knowledge check, and you can try it after you learn this section. And for remove, I don't think there are a lot of difference. Okay, so empty case, the first node is going to be removed case, and remove in the middle or at last. And here is a real remove. Okay, and here there is a question. There is a question that I want to discuss is for remove that. And suppose this is a cursor. This is a node that we identify that's going to be removed. So the way to do it is, so this is a precursor. So you set precursor next to cursors next. So this one will not be existed in the linked list. So it doesn't exist in linked list. But if you recall previously, all we learned is, so all of the linked list, so this is a cursor, okay, so it has a data parts and the next parts, okay. So then what will happen with this? So basically, this is a heap memory. So what will happen with it? Okay, because it's not going to be used anymore if we don't have some local variable to keep track of it. Then it will supposed to be gone. Is it? But if you recall, for memory management, if we have too many of these cases, then it's kind of they still take memory. Heap memory, is it? So if we don't do anything, it may have some problem, cause some problem for heap memory, is it? But we don't need to worry because in Java, this will be taken care by the garbage collection automatically. Okay, when scope is reached. So we don't need to worry. Okay, so because just think about if you have a linked list that has uh, maybe millions of items, and if you do a lot of insert and delete, if we do a lot of remove, is it? Then that's going to be a problem if memory is not so if the node is deleted, but the resource occupied by the node not released back to the system, it will cause memory leak. So if you implement in C++, if you just leave it like this, that's going to be an issue, is it? So you need to do like in C language, you dealloc, and in C++ do delete, is it, for the memory? Okay, but in Java, we don't need to worry because Java has garbage collection, okay? So it will be taken care of by the virtual machine itself. Okay, then let's continue. And in this implementation, we also add the method called contains. It's pretty straightforward, is it? But if you take a close look at the implementation over here, we use for each loop. And why we can do this? Because this linked list already implements iterable interface. Because it implements, that's why you can go ahead to use for each loop. Okay. For Elastic, then you cannot do that. And also over here, when we do the check, we use this equals. Okay, so we do the structure equality check instead of reference. Okay, so just be careful here. And also here, we also have a get method based on the index location. A linked list, suppose you are not supposed to have this indexing operation. Okay, but here let's just try to explain some concept. The return type is T, and T is a generic object. So be careful, it's object. Okay. And so we have some scenario if empty list, then no way to check that. Otherwise, you do the um, traversing to try to find the location. Is it based on the location? Now, if you cannot find it, it's through exception. Is it? If you does find it, you want to return the contents of the object. So here, did you see? We return deep copy instead of the reference, instead of the shallow copy. Okay, because for consideration of the secure coding, okay, it's recommended that you just create a copy to return it. Okay. And the toString. And over here, then this time we change. We don't use that traversing. Okay, no traversing. But instead, we use for each loop. Yeah, and the loop, and this is the linked list itself. Okay. And why we can do this again is because of the iterable interface we already implemented in this class. And here also shows the equals. So the structure equality check for the whole linked list. So this is a little bit of more complicated. It involves two levels of object. One is linked list. Okay, the second level is the object itself. That, so a couple of things we need to check. You first need to check if the passed in linked list is an empty one. Okay, and for equals method, you always the parameter always the object. Okay, and also you want to make sure the class you compared you pass in are the same class. Okay. And then the third one is over here, we create a link. we didn't create, we create a variable. Okay, its type is linked list. And we make it refer to this object, to the passed in. But because passed in is object, so we need to cast it to linked list. Okay, and then we start with the passed in. We want to compare. So you have two linked list. So this is this itself. Okay. So this is basically the other, suppose. And over here, because we have the second, so both point to the same as it. So second is a shallow copy. Copy of other. Or we call it, in this case, better just use alias of other. Okay. And so the cursor is going, so here is the cursor of this second. Okay. And when we do the loop for the linked list itself, we use for each loop. Why we can do this again is because the linked list already implemented the iterable interface. Okay. So then we are going to do one by one comparison. We compare the contents. Compare contents. So for this one, okay, we do the for each loop. And then we compare its contents, is it, with cursor's contents. Okay, cursor's contents. So it's data. And here again, we use the equals, and equals already defined in the car class, basically. Okay, and then you just need to advance the cursor. Okay, and for this one, there is no that because it's already for each loop. Okay, and in this linked list class, we also define a function called copy linked list, and it return a linked list. Okay, so basically, what this function try to do is try to do deep copy for linked list for basically object of this. Okay, so we first, because it's a deep copy, so you need to create memory. So on heap, so you do the new, okay, for the linked list. Okay, so here is the original. So that is this. Okay, so your cursor is set to the starting one. Okay, and then for the copy, how did we do it? Copies first. Is it copies first? Because then each one, you need to create the new node. So you have new node. Is it? And new node, how you create? You use the first so for its object itself, the data as you call the clone. So basically, in our car class, we already defined, is it? And also, generally speaking, if it's just an object, is it? And the clone is a deep copy. Okay, so you copy the contents also to here. Okay, also to here, and it's also deep copy. deep copy node by node, basically, is it? And then you advance the cursor advanced, is it? And then we also create. So this is a temp cursor created based on it. And then you also connect you see, you connect. So you set cursor to, so you advance, and here temp is a cursor as it point to this new node, okay? And then you also advance the temp cursor, okay? So then in this case, we we already see that it is a deep copy. Do node by node deep copy. So that's why previous I mentioned that it's two level of deep copy. Okay, each node going to do the deep copy. And then regarding the whole linked list, it's also deep copy. And this method, we can see this method is kind of close to Java collection linked list clone method. Okay, the collection, the data structure also has a method called clone, and it also is a deep copy. Okay, deep copy, then that means on heap memory, is it? So each list has its own memory location. Okay, then here you have that new, is it new linked list. Create memory, and then for each of the node, you also have the memory and then link them together. Okay, so that's a deep copy. And the good thing for the deep copy is we can prevent the kind of aliasing attack. Okay. And because we previously mentioned the iterable interface, if your class implements iterable interface, then you need to implement this iterator abstract method. And because it returns another interface, and in our implementation, then you need to define a class that implement that interface, okay? Because what you need to return, you cannot return an interface. You need to return some concrete objects. Concrete object. So that's why, and if you want to do new, is that you need to have a class. So that's how we create this linked list iterator class. And with this linked list iterator class, we can take a quick look. It only has a single data member called next node, and the type is node. Okay, and because this is inner class, that's why it can also access the node. And we have a constructor. The constructor, what it does is just set this next to the object itself is the first node. Okay. So set up the starting point. It's the first node. And has next, just check if it's already no, okay? And for its next, okay? Then if it's already reached the end, we just throw exception. Otherwise, because what it returns the current position's contents. So you get the current position's contents, and then you advance it. Okay. And also, I just want to mention over here, I didn't uh, so I just directly return the data. Okay, I didn't do the data clone. It is better to also do the data clone, is it? Because uh, for secure coding purpose, uh, better. This is kind of like the accessor. Okay, for accessor, generally speaking, for a strict secure consideration, you return a copy, return copy instead of object itself, so that you can protect. Okay, you can protect. Don't expose the inside. Is it just think about it for iterator, if you have a database, design database, and each of the record is this T that and your whole database is a linked list, and then when you do transaction, you expose everything. So that's not good. If your database is regarding username and password, that's going to be a big issue. Okay, so so here for security consideration, better use clone to return it. And for the iterator interface, uh, there is another abstract method called remove. You also needed to implement. And here we didn't do the exact implementation. Okay, we just kind of throw an exception. And next, let's take a look the driver part, how we test this linked list that we just wrote. Okay. So over here, we are going to create a list, linked list of car. Okay. And that car does meet the condition of the linked list because the car implements that T clonable interface. Okay. So initially it's empty. Is it? Okay, and then this is the first car we create. It has default. Okay. And then we just have a single car in this case, and we can test. You output the whole linked list. Okay. And then what we did is we just do the insert after. And we always insert after the first car, is it? And then we output the whole linked list. And over here, then we do call the copy list. So that's basically kind of like the clone method, okay, for the previous, this linked list that we just created, okay. And then you can check if both linked lists have the same contents. And then what's next is try to check the contains method. If it contains this car, okay. If it does contain, you call the remove method to remove it, okay. And for the first car, then we update, we call the set car. Okay, we update it. Okay. And after that, we can check because over here we call the remove method. We can check if the specified item is removed. Okay. And also let's check the list two. And this is a deep copy of one. Okay. And so one remove four, remove car four. So for this output doesn't supposed to contain four, is it? But for this one, because a deep copy, so it's supposed not to impact it. So it's supposed to still have the car four. Car four. Okay, we will take a look at the running result. And we can also test the get method. Okay. And what next is we can also using iterator for the loop. Okay, so we can call the iterator method, and then to use it has next and the next because we already implement the iterable interface. So all of these methods are available. Okay, so here we do the explicit using the external iterator to do the loop. Okay. One nice thing for you to use this because it support the remove method. Okay. Generally speaking, when you do the for loop, for each loop, you are not supposed to remove. Is it uh, in the general sense, okay, the loop is just accessible, but because the iterable interface support to remove, so even do the for each, even you do the remove, then the loop will not be terminated. It can continue. Okay, in the regular for loop, if you recall, like integer I from zero something, in that case, because the loop the iteration, number of iteration, generally speaking, unless your ending condition not defined, is that number of iteration is fixed. And if then inside you do the remove, then it will reduce the number of iterations. So that's why it will cause trouble. Okay. But if our iterable interface support the remove method, then that's a different story. Is it that because it supports, then it won't cause this kind of conflicts, so your loop can continue. Okay, so if if for the regular one, then it doesn't support. Okay, but in this case, the for each loop will support. But because we didn't implement the real remove, so the item will not be removed. Okay, and then because of the iterable interface, implemented. That's why over here you can use the for each loop. Okay, we can directly use it for each loop to get each individual car, okay, output its information, okay. And after we understand that, you can also try with our knowledge check. And what next we can do is we can try to run the program to see if it does what it's supposed to do. Yeah, if you take a look, that's the first time you create one node linked list. It just have one car, is it? After that, you see the car are inserted, okay, in the linked list. And the second list, yeah, exactly the same. If you do one by one check, okay. And then it says that we remove car, is it? So car 4, if you recall, that car 4 does not exist anymore, is it, in this one? But you see for the second one, car 4 is still here. So it proves it's a deep copy, okay. And then we update the first car. Okay, to new car, new color, is it? And then we use iterator to do the loop. Okay. And then we also use for each loop to loop the car. Okay. And this one is knowledge checks answer. Okay, so that's the end of the discussion about simply linked list, also in support for each loop with the implementation of the iterable interface. Okay, so we will come back to discuss the next section in the next lecture. Thank you.